Now this video is for integrated 3. It is logarithm review number 2. This is the second part of the logarithm worksheet, but this one is calculator allowed. So these we're going to be putting into our calculator. And two ways I could put this in depending on the calculator I am using. I could do change of base and go log base 10. So I'm not going to put any base written down. I'm going to say log of 22 divided by log of 6, and I could put that in my calculator. Or I could straight put it in like this if I have one with the base. So I'm going to use Desmos here. Let me just get it up on my screen. And so if I'm using Desmos, and I want to do log base 6 of 22, I could do this two ways. I could type in log, and then I can do shift and underline 6, arrow out of 22, and I'll get a 1 point. Let's see, did it say how many places it wants? 4 digits after the decimal. So 1.7251. 1.7251. So 1.7251. Now, if I had a calculator that did not allow me to do that base, then I could instead take log of 22 divided by log of 6, and you see I get the same answer. That's using change of base. Ln of 23, remember this is base E. So when you should have a natural logarithm button on your calculator, or on this, I can type in ln of, I want to say it was 23. Yeah, ln of 23. And I get a 3.1355 because that 49 is going to be pushed up to a, so basically this 54 will be pushed up to a 54. So 3.355. So 3.1. Um, 3.1355. Now on this one, I can type it in as I see it, and I'll do that here in a second, or I can really clean this up. The top is really log of 10. Why? Because I am subtracting logs, so that means I'm really taking 20 divided by 2 and getting 10 over 6. And when I'm adding logs, I'm really multiplying this. So this is log of 100. I really truly could do this without a calculator. Log of 10 is really log base 10 of 10, which is 1. Log of 100 is really log base 10 of 100, which is 2. And 6 times 2 is 12. And so it's a 1/12. Or I can put it in my calculator. And so when I'm doing this, I am going to just stretch this out a little bit. So when I'm doing this, I'm going to type in, let me just get my fraction, log of 20 minus log of 2. Now, if I don't have a fraction bar on my calculator, I want to put parentheses around log of 20 minus log of 2. 6 times log of 25 plus log of 4. And you see I get 0.8 0.083 repeating. If I hit this, it'll give it to me as a 1/12. Okay, so 1/12. Okay, on number 4, I can put this in my calculator either as I see it, or I could also type in log of 5 over log of 9, where again, these are base 10. So I will do both of those. So if I am doing log of 5 divided by log of 9, you see I get 0.7325 if I round. I could also have just typed in log base 9 of 5, and you see I get the same thing. So 0.7325. So 0.7325. On the next one, I am going to take the log of both sides. So I am going to take log of 3 to the 2x minus 3 equals log of 21. When I take log of something to the power, remember that power really can move in front. So this is going to be a 2x minus 3 times log of 3 equals log of 21. I am going to divide both sides by log of 3. So I'm going to get 2x minus 3 is equal to log of 21 over log of 3. Then I am going to add 3 to both sides. So I'm going to take this log of 21 over log of 3, and I'm going to add 3. And my last step is going to be to divide by 2, but let me get this answer first. So I am, let's move this over a little bit. So I am going to do log of 21 divided by log of 3. And then I'm adding 3 onto that. And so I get a 5.7712, 5.7712. And my last step is to divide that by 2. Okay, because I had a 2x really. So I divide that by 2, I divide that by 2, and that's going to give me my answer. So let me get that back up. So I'm going to take this whole thing and divide that by 2, and I get a 2.8856, a 2.8856. Now that's one way to have done this. Another way to have done this, let me just scooch this a little bit, is I'm going to put it here and then I'm going to erase it. And here I'll do it in green. So I could have rewritten this in logarithmic form. This is really log base 3 of 21 equals 2x minus 3. So I'm going to add 3 to log base 3 of 21. Then I'm going to divide by 2. And I'm going to put that in my calculator. And when I put that in my calculator, and I'm going to have log base 3 of 21, and I'm going to add 3 onto that. And then that would all be in parentheses if I didn't have a fraction bar. Then I'm going to divide by 2. You see I get the same answer. Okay, on number 6. So let me just get rid of this. Or here, I'm going to do this. I am going to take this answer, this problem here, and I'm going to work it out right here. Okay. So the very first thing I do in this one is I'm going to divide both sides by 50. So when I take 1,000 divided by 50, I am going to get a 20. Okay, dividing both sides by 50. Now I can log both sides, and when I log this side, the 2x is going to come in front. Log of 1.04 is equal to log of 20. I'm going to get the x by itself. And when I'm doing that, I need to get rid of the 2 and this log of 1.04. So what I'm going to do is I'm going to take log of 20 divided by 2 log of 1.04. And if I'm not using a fraction, I want to make sure that I put parentheses around the whole denominator. So I'm going to do log of 20 over 2 log of 1.04. And I get for my answer, sorry, let me get that back up. 38.1907. So 38.1907. So 1907. Now, I could have also at this point, when I'm dealing with this, I could have rewritten that in logarithmic form, which is going to be log base 1.04 of 20 is equal to 2x. And then I could have taken log base 1.04 of 20 and divided it by 2 to get x. And when I do that, and I take log of 1.04 of 20, and I'm going to divide that whole thing by 2, you see I get the same answer. So it really just depends on whether you prefer to rewrite that in logarithmic form or log both sides. But you don't do any of that until you get your base, which is this 1.04 to the 2x by itself, and make sure that that 50 is not there. Okay, on number 7. Paul has $2,000 in his bank account, which earns 10% annual interest compounded quarterly. How long will it take him to have $3,000 in the bank? This type of problem is from integrated 1. So when we have compound interest and it's 10%, we have to look and see how it's compounded. It's compounded quarterly. That means I'm getting it 4 times a year. Now I'm not getting 10% 4 times a year. I'm getting 10% split into 4 equal increments. So if I was to take 0.10 divided by 4, 0.10 divided by 4, I see I get 0.025. So that means I'm getting about 2.5% 4 times a year. So my equation is going to be $2,000 in the bank times 1.025 because I'm increasing by 2.5% 4 times a year for X years. And I get $3,000. So now I'm going to solve it like the other problem. I'm going to divide both sides by 2,000. So I'm going to get 1.025 to the 4x is basically equal to 1.5 when I put that in my calculator. What I'm going to do is I'm going to rewrite this in logarithmic form. So this is going to be log of 1.025 of 1.5 is equal to 4x. And then I am going to take log of 1.025 of 1.5, divide it by 4 to get my answer. Again, I could have logged both sides. I'm just going to do it this way. I think it saves a couple steps. So I'm going to take log base 1.025 of 1.5, and then I'm going to divide that by 4, and it's going to be 4.1051 years. So 4.1051 years. On number 8, a $14,000 machine depreciates exponentially, losing 6% of the value it had at the beginning of the year. In how many years will be worth $10,000? So we're starting with something that's $14,000. We are losing 6%, which means the multiplier is going to be 0.96. We're losing, sorry, not 0.96, 0.94. We're losing 6%, but we still have 94%. Raised to the power x equals 10,000. So I'm going to get 0.94 to the power x is equal to, I'm going to divide both sides by 14,000. And I get, I'm going to leave it as a fraction, 5/7. It's a decimal. So when I did it, I actually just divided 10 by 14. But as a decimal, it's this. But as a fraction, it's 5/7. So I'm just going to leave it as this fraction. It's easier to write. Then what I'm going to do, let me just kind of separate this. Then what I'm going to do is I'm going to rewrite this in logarithmic form or log both sides, whichever method you prefer. So I'm going to write log base 0.94 of 5/7 equals x, and I'm just going to put that in my calculator. So I'm going to take log base 0.94 of 5/7, and I get 5.4379. So 5.4379 years. A fossil sample now contains 60 milligrams of carbon-14. There were originally 150 milligrams of carbon-14 in the sample. If the half-life of carbon-14 is 5,570 years, how old will the fossil be to the nearest 100 years? Okay, so again, this is integrated 1. Half-lives, we learned in integrated 1. So the way I personally would set this up is we are starting with 150 milligrams. It is a half-life, so I'm timesing it by 1/2, or I'm just going to write 0.5 to the power of, well, I don't take half every year. I take half every 5,570 years. So I'm going to raise this to the x over 5570. That's my exponent. And I want to know when it will be 60. So I'm going to divide both sides by 150. So I'm going to 0.5 raised to the x over 5570 equals 60 over 150, 6 over 15. So 6 over 15, divide top and bottom by 3. It's going to be 2 over 5. Okay, or 0.4. So I can just put this as 0.4. Okay, as 0.4 if I put in my calculator. Now I can log both sides, or I can rewrite this in logarithmic form. So if I write this in logarithmic form, this is going to be log base 0.5 of 0.4 is equal to x over 5570. To get rid of that 5570, I'm going to times both sides. 55570, 5570. So here those would cancel out. And then I am going to put this in my calculator. So I am going to put 5570 times log of 0.5 base 0.5 of 0.4. And I get 7,363. Well, they want it to the nearest 100 years. So 7,400 is what that's going to round up to. So 7,400 what it's going to round up to years. And the last one here. So Page's car is a classic car which appreciates in value 12%. So that means it's increasing by 12%. If her car is currently worth $18,000, how long will it take for her car to be worth $36,000 in value? So we're going to take $18,000. It's appreciating, so it's gaining 12%. So the multiplier is going to be 1.12. Raised to the power x is equal to 36000. I'm going to divide by 18,000. And 18,000 is actually half of 36,000, so that's going to be equal to 2. I'm going to rewrite this in logarithmic form. Log of 1.12, log base 1.12 of 2 equals x. And I can put this into my calculator. Just move this over a little bit. So when I put this in my calculator, log base 1.12 of 2, I get 6.1163 years. 6.1163 years. And that's the end of the second video.